In these two examples, we are going to be doing a summation of a linear and summation of a quadratic. And so we would be adding 8 plus 9 plus 10 plus 11 plus 12 all the way up to 24. Then here would be 7 squared plus 8 squared plus 9 squared. So we're going to get some pretty decent numbers on this. And so the idea of this is somebody created some formulas. And so we did an example like this back here where we had this quadratic. We broke it up into its parts and we applied these formulas to figure out some shortcuts of these summations. So the problem is on these formulas, we have to go from one to some value. And our two examples don't go from one to example or one to whatever the value is. So we need to do some sort of shift in order to figure this out. Now, the interesting thing is when we shift this over, we're going to make this, I'm just going to give it a different letter just to kind of differentiate between the two, is I'm going to need to go from 8 to 1. Now, I'm going to treat this very similar to something that you've done in a prior class of when you had some sort of an equation, and if you shifted, this would be like shifting left 7. And if you remember that graphically, the graph shifts to the left 7, but we write it as an x plus 7 squared. Well, that's exactly what we're going to do. So if we're shifting this value left 7, right, i.e. we're subtracting 7, that means we're subtracting 7 here. So we're shifting left 7 here. And that means this equation gets shifted left 7. But to shift it left 7, visually, algebraically, we would be adding 7. So we'd be doing the exact same kind of a math that we've done in prior classes. So shifting left 7 means shifting left, we're doing the opposite, right? If you remember, you have this x minus your h and k's kind of a thing. And so this was always an opposite. All right, so basically this summation turns into this, which then we rewrite as I equals 1 to 17 of I, and then plus the summation I equals 1 to 17 of 7. And then we have our formulas. So this is our I, and then this is our just of a constant. So we have these formulas that we'll be plugging in. We'll do some calculator work here a little bit. But the idea is not to just throw this into a graphing calculator and we get it. Like, what's the process? What's the programming kind of underlying the calculator? So let's plug this in. So we're going from 1 to 17, like the formula needs us to do. So we're going to have a 17 times 17 plus 1 divided by 2 for that first term. So 17 times 17 plus 1 divided by 2 plus, if we have a constant, it's just the constant times whatever the number is that you're going to. So our constant is 7, and then times 17. All right, and then from there, we're looking at a 17 times 18 divided by 2 plus 7 times 17. And then, so I'm just going to show that we can kind of get away with a really basic calculator out of this. All right, so here's our stuff. And so I'm going to simplify this. So where we're doing 17 times 9 gets us 153 plus 7 times 17 gets us 119. And then those two added together gets us 272. And by all means, I would go back, throw this into a calculator with the appropriate, 153 plus the 119. So that turned into 153, that turned into 119, and then the sum of that. But I would definitely plug this back into a calculator and make sure that you're getting the exact same thing. Am I comfortable with how the formula develops and adjusts? Right, so let's do one more. And this time we're doing a quadratic that needs to shift. So we're going to rewrite this. So we're shifting from 7 to 1. Excuse me. So that is a shift of left 6. So if it's a left 6, that means in my formula, I'm going to be adding 6. But it's squared, and we're going to subtract 6 on this one as well. So that's going to take us to 21. All right, so that's where we're at. Now, bad news on this one is I need to rewrite this one into terms like this, right? I don't have a formula up here for that kind of a situation, so I need to actually multiply it out. So if I multiply this out, that's going to get me, if I did I plus 6 times another I plus 6, I'm going to get an I squared. And then I get a 6i plus another 6i, so plus 12i, and then plus 36. So I need to rewrite this whole thing. So I equals 1 to 21. And then I'm going to have I squared. And then here I'm going to rewrite it as 12 I equals 1 to 21 of I plus just this constant. I equals 1, 21, 36. Okay, so now I have my formulas again. So I have an I squared. So that's our formula. So I have n plus 1, 2n plus 1. So my n is 21. So I'm going to have 21, and then it was n plus 1. So 21 plus 1 times 2 times n plus 1 divided by 6 plus, I have a 12 in front of this whole thing. And then I'm going to have my formula again, similar to what we had on this one. So I have my n plus 1. So my n is 21. And then n plus 1 divided by 2. And so I'm just applying that formula right there. And then my last one is my constant times my n. And my constant is 36 times 21. Okay, so let's see if we can simplify it a little bit, and then we can use a basic calculator to kind of get the values all put together. So I am looking at 21 times 22 times 42 plus 1 is 43, all divided by 6 plus 12 times 21 times 22 over 2 plus, let's figure out what 36 times 21 is. 36 times 36 times 21, 756. All right, so before I throw all these in, let me kind of pick away at this just real quick. I can take a 2 out of both of those two and make that a 3 and make that an 11. I can take a 3 out of that, make that a 7, make that a 1. So no more fraction. I can take a 2 out of the 22 and make it an 11. So now here I'm really looking at 7 times 11 times 43. So 7 times 11 times 43. So it gets me 3311 plus 12 times 2, 21 times 11 times 21 times 11 equals 2772 plus our 756. And if I add all those together, so I already have that, plus 3311 plus 756, adds up to a total of 6839. So point of this was that you had these summations, and these summations are great when we have it in the appropriate situation where we start at 1 and we're going to a value. So our formulas only work for that. So sometimes we need to adjust, and we're going to adjust it. And the good thing about it is it's adjusting it like that we've done in the past with some graphs. So if you're shifting left, if you're shifting right, you're just adding or subtracting the opposite of whatever the value is.